So 12.4, we're into day 2 of logarithms. So logarithms were the opposite yesterday of what? E-word. Exponential. So exponential, logarithms, they're opposites. So what we're going to do today is just some more kind of exponent-y kind of things, just opposites. So here's a flashback to something you should know, and if you don't, we'll learn it because it's important to you. If you have a multiply problem with exponents, what was the rule to do there? We'd add the exponents, and this would come out x to the fifth. So today, multiplying and adding are still going to continue to have some relationship over here. Dividing, what did we do when we divided an exponent world? We'd subtract, so this would be x to the 6. So when we make our way here in a minute, dividing, subtracting, still have a link. When powers were getting involved with other powers, you multiply, this would be x to the 12. We're going to have something like that today. We're multiplying powers, they'll go together, just in an inside-out logarithm world. Question about those basic things which we should know that we're trying to just do inside-out today. Okay. So here's the new ideas, 3 main ideas of the day. Kind of a choice you're faced sometimes in math. Would you rather have one problem and have it be big, or have 2 problems and have them be little? And I think that's like, I don't know, depends on the problem maybe, I think would be a fairest answer. So what we're doing today is basically facing that choice and being able to work that choice in either direction. If I give you one logarithm problem with a couple things, sometimes that's the way you want it to be. Sometimes you'd rather have 2 logarithm problems where the stuff is littler. So notice, what was this called? It's called the base. You notice that all of the bases need to be the same. So log base A, log base A, log base A, just copy, 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 copy. But instead of have one logarithm where there's a multiply going on, you could make 2 logarithm problems, and instead, what do you guess?
Subtract, add.
One of those 2.
Add.
Multiply has to do with add, where we came in. It still does. You can take one logarithm problem with multiply, make 2 logarithm problems where it's going to be an add. So repeat the skill. If I want to take this one logarithm problem where there's a multiply,
Add.
so this would be log
2.
base 2, 4
Plus.
plus log 2,
16.
true.
Send it.
That's it.
So boing.
Question about that? So anything you can go forward,
Backward.
go back. So if I give you instead 2 logarithm problems where there's an add, you could instead trade me for 1 logarithm problem,
3.
base 3.
X.
And parentheses.
Parentheses X 5Y.
Yeah, take those pieces and just multiply it up, something like 5xy. And it's debatable which better. Okay, sometimes you're better off with 1 logarithm problem, but it's got like a bunch of stuff. Sometimes you're better with 2 logarithm problems that are littler. There's a time and place for both of those groups. Question about that? So how do you suppose this one's going to go in a new category?
Subtract.
It's going to be a subtract. Multiply made us add. Divide is going to make us subtract. So this would be log
Base A.
base A
X.
x minus
Log base A.
log base A and 1. And again, as I said yesterday, if we were typing this on a device of some sort, log, the fraction, log x, subtract, log y, all that stuff would be on the same line. Same size, same line, same spacing, same everything. The subscripts are the only thing that get out of line. They'd be like a little bit littler and they'd be pushed down into the next. So one more time, same skill. This would be
Log base 3. Ow.
log base 3 of
5.
true,
Minus. Log base 3 of 7.
true.
Yeah.
Something there.
Archie, with me.
So then kick it into reverse. If I give you 2 logarithms where there's a subtract, you could give me back one logarithm where you divide. This would have a base of
8,
8, and you'd stick
10x,
2y.
2y.
it's your story.
I was about to say 7.
Question about any of that?
Life's great.
Okay, there's one answer we could improve slightly.
The last one.
The last one. What should we always look to do when we see fractioning? Reduce. So what can we do with this?
5x over y.
This would be better to do a little bit of a cancel, reduce kind of move. 5x over y would be ideal. Question about that? If we wanted to use yesterday's tricks, we could change that to just a number. Can anybody use yesterday's homework and lesson tricks and tell me what number that is?
Wait, I lost my
Give me a second.
Anybody memories from yesterday? If I said compute that,
2?
it is 2. Because what we try to do is 2 times 2 times 2 times 2 times 2 and count fingers till we land on 4. 2 times 2, we already landed on 4. You see another one that we could do that? 16. If we try to do 2 times 2 times 2 till we land on 16, that's 4. So a better answer for this might be 6. If you wanted to do that, but that's not the main point of today. You can't really do that here because
Nothing can make it fine.
3 times 3 times 3, you can't make it land on 5. And 3 times 3 times 3, you can't make it land on 7. That's a question for another day. Question about beginning here. So, third idea is if we have exponents involved. And this is going to be the easiest of the ideas. What did we think over there we ran into when exponents got involved? So, multiply made us add. Divide made us subtract. What did exponents make us do? Exponents made us multiply. So what we're going to do is create a multiplication kind of thing. Whatever the exponent is, can just slide to the front where there's multiplication action there. So the y could go to the front and leave the log, the base a, and the x all stand pat. That's the easiest and actually most useful of the tricks.
Is that all you do?
That's all you do. So for this, I'd want to go 7, log base 3 of 10. If I reverse that, I'd go logarithm
Base 8.
base 8
Okay.
to the 5th. And then maybe the book would want us to make 2 to the 5th into 32, but maybe not. Check the back, see what they're doing. If they're making the exponents be done, then do them. If they're not, then who cares? Question about that? So that's the 3 basic rules. Again, multiply makes you add, divide made us,
Right.
and then exponents made us multiply. There's nothing really new to that. It's just inside out of the way you're used to seeing these facts. Now here's some combo moves. So this has some multiplying and some exponents. And there's like a bunch of letters. So if they want us to tear this up into pieces, how many logarithm pieces could we make? 3. One of the logarithms would have x. Another logarithm would have y. The third logarithm would have z. So if there's 3 letters that are all multiplying, we could tear it up into 3 pieces. 2 other things need to happen here to be correct.
The log of x would have 2.
Yeah, the log x would have a 2 in front of it because the powers are going to slide to the front.
Y would have 2.
The y would have a 3 in front of it. And then we're just missing a couple symbols. Pluses because everything over there was multiplied. So we could tear that all up into a bunch of little bite-sized chunks. Question about that? So tear this one up. How many items would we make? 3. So one logarithm mainly about x, another one about
Y.
and another one about z.
That's
2 with the x.
2 in front of the x stuff.
Adding 3.
Adding
3 y.
3 in front of the y thing.
Minus 4.
Subtracting for the z. All true story. Yep. Something there. Okay, this we need to have a memory of yesterday as well as early in the year. Roots, there's another way that we can write roots. Instead of writing this as a root, there was something we bumped into yesterday. That's true, but that wasn't what we bumped into yesterday. How can we write roots a different way? Fraction powers. Roots and fraction powers are buddies. So this would have, another way to write that is that there's a half power going on there. So what would we want to do with that half? Ship it out to the front. So we could go half, shipped out to the front. What would the half go with? With the x, with the y, with the z, or with everybody?
Everybody?
Everybody. How can we make this half go with everybody? Parentheses is correct. So the root we could write as a half. The half could ship out to the front, but we're going to need parentheses for that half to go with everybody because it does go with everybody. Something about that. So how many logs do I have? 3. 1 with x, 1 with y, 1 with z,
2 with the x.
2 with the x,
Plus nothing.
nothing to do with the y, minus
Minus 5.
5 with the z, call it a day. We could distribute if we wanted to, but I don't see why we wouldn't. Question about combo effort, working forward. Anybody notice it's anything different about this cluster compared to everything else I've done yesterday or today? There was no base, is correct. So there is an invisible base, so now's as good of a time to drop this knowledge on you as any. If you don't see a base, there's an invisible base of 10. So whether I write that or whether I don't write that doesn't make any difference. If it's anything with a log base 10 and you're just not in the mood to write the 10, don't write the 10, it's still there. We have a base 10 number system. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like place values, 10, 100,000. You know, it's all based on 10s, our numbering system. The logarithm system is all based on 10s because that's how our numbers work. Question about that? Why don't you give another little turn? I don't know that we need to stop. We can at least just do a little turn of that so we're in view.
Yeah, we're good.
Final column, and then I'm out of space, but I have like 3 more problems up my sleeve I'll need to carve out a space for somewhere. But this upper right corner here, what we're doing here is the opposite of what we just did a second ago. Instead of having one big logarithm and making a bunch of little ones, we could take a bunch of little ones and make one big one. So this is going to be a logarithm of some kind of a like giant thing. If we go in reverse order,
X to the 5th.
x would go to the 5th,
Y to the 3rd.
y to the 3rd,
Z to the
z
2nd.
to the 2nd. Something about that. So this one, logarithm, some kind of big thing.
X to the 5th
On top of.
Okay, so we're going to get a fraction thing. X to the 5th is top,
Y to the 2nd.
y second is bottom,
And then
Z7 on the bottom.
z7, y is it also on the bottom? That is correct.
Check.
Subtract. Anybody that's subtracting should go on the bottom. Anybody that's adding should go on the top. Something about that. One more time. So one big logarithm, fraction, no fraction, fraction. Anytime there is what, we know fraction. Subtracting. So subtracting is going to divide, go fraction.
X on the top.
X on the top,
Well, it's root
Y
x.
cubed.
y cubed on the bottom.
Half outside the parentheses.
Oh, root.
And then half how on the x? We could go exponent of half, or if we want to recycle another idea from earlier, we could write the half power as a root. I don't care. But either root x or x to the half flips up to be a power, and fraction powers are roots. Question about that? It seems like you got that. I've always felt like this part of the lesson is fairly easy. I don't know, relative to Algebra 2 in May. what you might have expected to be doing. This last group is going to make people a little bit madder because it's going to require a little bit of math creativity. Okay, so on this first bunch of stuff, if you just kind of do what I said, you're going to get them all right. This, it's not as simple as just do what I say. You've got to come up with like creative thoughts of your own, and I can try to give you some tips, but we'll see how this goes. So the last group of homework, they're going to tell you a decimal number for log of 2. They're going to tell you a decimal number for log of 3. They're going to tell you that the log of 10 is 1. And they're going to expect you to find a way to use the multiply tricks, the divide tricks, and the exponent tricks, as well as these numbers, to come up with answers. So here's what you're going to try to do is, definitely it's a logarithm. Make up your own homemade math problem where 6 is the answer. You're only allowed to use 2, 3, 10, and you have to be some combination of multiply or divide or exponents. So you couldn't, for example, say 10 minus 2 minus 2. Like, that's not a thing. Multiply is a thing, divide is a thing, exponents is a thing, adding, subtracting, any other weird math is not a thing. So this one's not that bad. What homemade math problem could you create using 2 times 3? Multiplying is a good trick to use because we have a multiplying like idea that we came in with. If I have one logarithm that's multiplied, you can make 2 that are add. So that's log 2 plus log 3. Log of 2 they're telling you is this. Log of 3 they're telling you is that. And we just decided that we need to add. So add those numbers up. 7, 7, 7, 8. Question about that. So 40. We need a homemade math problem. And it doesn't have to just be one multiplication or one operation. You might have a couple things going on. But we're only using 10s, 3s, 2s. And trying to produce 40 somehow from math creativity.
2 squared times 10.
It could be 2 squared times 10 or 2 times 2 times 10. However you want to write that really, doesn't make that much of a difference. Since this is a multiply creativity world we made, now logarithm tricks of the day, we're gonna add them. How many things are we gonna add? 3. We're gonna go log of 2 plus another log of 2
Plus log 10.
plus log 10. So we grab those numbers. This adds this, adds this.
1.602.
1.602. Something there. Instant replay. I got 2 simultaneous sort of suggestions, the one I wrote down and this one. If we had written down that one, we wouldn't have 3 pieces, we'd have 2.
And you put a 2 in front of 1.
We'd go 2 in front of that piece. So we'd go 2 times this number, add that, the result would be the same. So might people come up with different creative math to do there? Sure. You just need to find something that works. This one's a little worse. It would be a 3 divided by 2. So 1.5, this is going to be a section where some people are instantly going to be like, that's 3 over 2. And other people are going to be like, how in the world can I get 1.5? If it doesn't come to you within about 30 to 60 seconds, I'd say it's time to move on to the next one. Don't shut down the homework completely. Well, I can't do that one, I'm off for the night. But if you have one you can't do, just skip that one, go to the next one, see if the next one presents itself better to you. But 1.5, I mean, you can play around with that in your mind. Well, 1.5, that's the same as 1.5. Can I play around with 1.5s? Well, I've made those improper before. Hey, 3 over 2, yeah, that's a win. So this would then break down using today's knowledge to be log 3 minus log 2. So we grab this one minus that one. It's 176. Something about that. Then here's a trick we did earlier today, but it didn't happen fast. Roots, what can we do with roots? Powers, what kind of powers? Half powers. This root is the same thing as having a half power. The half is able to, what can we do with powers? Cut them to the front. So this would be the same as half log 6. Fortunately for us, we already did log 6. So we just need to do half the answer from here when we already did log 6. We don't need to repeat all those steps. We already know that's going to end up on 778. So half of 778 is 389. Something about that. Like I said, I have 3 more. I think I'm just going to erase and do them here. Does anybody need a minute to like capture this before I? Yeah, go ahead. You can grab a picture of that if you want before I clear a little bit of space. My 3 new ones might as well just live here, I think. Anybody need a sec to capture pictures or capture notes with your pencil in this little zone? I think there's 3 more. I know I ran out of space, and do I need to re-clear something when I put these all up? Yep, we'll do those and then call it a day. So 5th roots. What do you think about 5th roots?
1/5.
That is a 1/5 power. And what can we do with any powers? Times into the front. So that would be 1/5 log 1.5. Why am I not real worried about a bunch of details on doing log of 1.5? We already did that a minute ago. So 1/5 of whatever that was before I erased it, and I don't have that written down. Somebody, what was the 1.5?
3/2.
Is it the 176?
Yes.
Yeah. So we just, grab a machine if you need it, take this and divide by 5, and you're gonna get an 0.352. Something about that. Logarithm there. 100th?
What if you did a negative power?
Negative power is the name of the game, because we discussed that yesterday. What do negative powers do? They flip things. So if I just gave you 100, you would have gone 10 squared. 10 squared to do the 100 would have been nicer and easier. But since I flipped it, it's not that big of a fuss. That's 10 to the -2. Question about that move? And then what can we do about powers? Divide them to the front. So we'd have -2 in front of log 10. And the log of 10 is gifted to you as 1. So -2 times 1 is -2. About that. This one, before I try to make up the problem, I might split this one problem up into 2. Again, the question at the beginning of the period is, are you better with one problem that's complicated or 2 problems that are less complicated? And the answer is, I don't know. But here, I think you'd be better with 2 problems that are less complicated. But it's trade to divide for minus. Then I don't think 4 is a bad trade. 4 you could trade either for 2 squared or
2 times 2.
2 times 2. Doesn't really matter. I'll go for 2 squared. 27's a little harder. 3 cubed. Or 3 times 3. Times 3. Powers. Go to the front. So we could make this 2 in front of log 2 minus
3 log 3.
3 in front of log 3. So you'd want to take 2 times that
6.
minus 3 times that.
I'm not doing that minus.
So
Nope.
That would be
41.
It's negative.
602. Maybe that? Somebody do it. 2 times the 0.301 minus 3 times the 0.477.
-0.829.
829, that's very possible. Maybe I didn't borrow right or something, but
the calculator's wrong.
Okay.
could happen. I would trust the calculator a little bit more than me right there.
Not your calculator.
Good context. Question about that? So here's how the homework stacks up. We are on 522, spills into 523. So 522, the first, I'm gonna say 15, are pretty easy. They're like what we did up until this very first line that I drew, where we just learned the 3 basic properties. From 16 to 28 are the turned one big logarithm into multiple pieces, like 2 or 3 pieces. Then from 19 to 24, we're more like this, take multiple pieces and turn it into a single problem. And then I think life goes up into the creative world at 25. From 25 to the end, you have to create your own problem and then work it.
What number does it go to?
So we're going to 36. And I think we're doing them all. Let me pull this paper out of here. Where'd it go? There it is. Yeah, 522. We're just rolling to 36. Question about that life? Let's go brief homework helpers to take a peek at 517. 517, can you route that diagonally back to her just so she can look at her answers that came in ahead of time? So let me give you at least one answer per group so you can verify what you're doing. Go ahead, put your hands down. I'm going to say no. Yeah, I'm going to say no, not quite yet. Just let's talk homework page and then I'll be open for business after that. For 517, for number 1, we'd want to go log base who? 10, because 10 is the base for the logarithm problem, because 10 was the base for the exponent problem. On the other side of the equals, who's going to be the solo artist number? 3, because 1,000 already had his turn to be the solo artist. So we go log base 10 of 1,000 equals 3. Or you go 3 equals log base 10 of 1,000. You have a little bit of flexibility, but you need the log to have a base of 10, you need the log world to have the 1,000, you need the 3 by itself, and that's kind of like what you're doing 1 to 9. Let's do 9. 9, we go log base A of
C.
equals,
Negative.
okay, and then we're 9 of those we did. Anybody 1 to 9, anything there that you're not sure what's up? 10, we're going in reverse. So 10, we want to go who to a power?
3t.
3 to a power, because 3 was the base. 3 to the power of t, because t no longer gets to be alone. It had its turn alone. And that would equal 8. So 3 to the t equals 8 is 10's game. Something 10. Let's skip to 18. 18, who to the what is who?
KC.
K to the c equals a. Or a equals k to the c. Doesn't matter. Something to 18, anything? 19, you'd bust out fingers, or no, 19, sorry, we're not busting out fingers yet. 19, we'd rewrite this and then figure it out. So 19, your first move is write a power with problems. So who to the who is who?
3 squared equals x.
3 squared equals x. And since x is alone, just do the math.
9.
It's 9. 23 works in a negative power, so that might have made people mad. It is a half. Fraction powers there to, negatives or fractions, because negatives powers flip things. 24 is another flippy thing. It is 1/9. 25 is more of a rooty kind of thing, because it's a fraction power. 25. You'd have to do a root in your process.
I just got 2.
It is 2. 26, there's a fraction power, so you'd have to do a root.
2,
It is 2. 27 is a fraction power, so you're doing a root.
3.
It's 3. Anybody something on those? Have any trouble on that zone? 28 is where we break the fingers out. So 28, what you're looking to do is 2 times 2 times 2 times 2 times 2 times 2 times 2. Sooner or later, you land on 64. How many fingers are showing at that
6.
point? It is 6. 32 is a little bit of a trickier one. It is -1, a negative answer because it's a negative power that gets you a flip. 34, a little bit of a trickier one, needing to know an earlier life fact.
0.
It is 0. Anything to the 0 power is 1, is what that fact is. 35 is based on an earlier life trick. It is 1. The trick is that anything to the 1 is itself. Other than that, that zone is all somewhat like 28. But I did the tricky once. Anything to 36. Then the last group is just easy money. When there's 3 to a power, and there's also a log base 3 in the neighborhood, those two items just cancel out. So 37, you're just left with
4,
then
10,
and
9,
and
9.
uh,
Is that an A?
A. Yeah. Well,
My
that's it,
9s
but
and A's look the
that's
same.
all right. Anybody 517? Anything that was confusing you at all about how to do that page?
Did it.
Okay, so that's a wrap on that. We've